Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving last question number 4 from exercise 1.4. So observe that in this question, we have to differentiate this first function with respect to another function. Generally, we are differentiating a function with respect to variable, and generally we are differentiating the function with respect to which variable? X. Generally, variable we are denoting by what? X. But here question is to differentiate one function with respect to what? Another function. Instead of differentiating function with respect to variable, we have to differentiate one function with respect to what? Another function. In such cases, we are making the use of formula of parametric function to find out our required differentiation. So try to understand how to apply the formula of derivative of parametric function whenever we are differentiating one function with respect to what? Another function. So here we are denoting first function. In solution, let us denote the first function, say by u. Let u is equal to x sine x and v is equals to, let us denote the second function by v. V is equal to tan x. Now question is what? Differentiate first function with respect to another function. But first function we have denoted by what? U, and second function we have denoted by what? V. Question is to differentiate x sine x with respect to tan x, means in other word we can say that x sine x means what? U, means we have to differentiate u with respect to what? V. V means what? Tan x, because first function we have denoted by u, we have to differentiate first function with respect to second, means we have to differentiate u with respect to v. That is our question. Means we have to find out du upon dv. Again, see here we have to differentiate this function x sine x with respect to what? Tan x. But x sine x means what? U, and tan x means what? V. If we have to differentiate x sine x with respect to tan x, means indirectly we are saying that we are differentiating u with respect to v, because x sine x means u and tan x means what? V. Now value of u is also in terms of x and v is also in terms of what? X, means x is what? Parameter. And to find out differentiation of parametric function, we have seen the method also up to question number 3. Same method we are applying here. So first consider u. Consider u is equals to, what is the value of u here? X sine x. Now value of u is in terms of x, means here x is the parameter. So differentiate it with respect to x. So derivative of u with respect to x is denoted by du upon dx. On this side, to find out differentiation, we have to apply what? Product rule. According to product rule, keep first term as it is, derivative of second term. Second term means derivative of sine x, plus second term as it is, sine x as it is, into derivative of first term. What is first term here? X. So which is equal to, x keep it as it is, derivative of sine x, it's cos x, plus sine x keep it as it is. What is the derivative of x? 1. So which is equal to x cos x plus sine x. Now we are considering v. What is v? V is equal to tan x. Value of u, v is equal to tan x. And we have to differentiate v also with respect to parameter x. So differentiate it with respect to x. So derivative of v with respect to x is denoted by dv by dx, and we know that derivative of tan x will be equals to what? Sec square x. In this way we have got the differentiation of u also and v also. Now we are making the use of our formula to find out our required value. So now let us try to find out our required value, means derivative of u with respect to v. So here it can be written as du by dx divided by dv by dx, because value of u is also in terms of x and v is also in terms of x, means x is our parameter and our required value is what? Du upon dv. So which is equal to, now replace du by dx by its value. What is its value? X cos x plus sine x, and v is equal dv upon dx, its value is equal to sec square x, and this is nothing but our required derivative. So hope the idea about how to find out derivative of one function with respect to another function is very clear to you. Same method we are applying in remaining all example from this exercise, from this question number 4. Now observe the second example. In this second example also we have to differentiate one function with respect to another function. So same method we are applying which we have seen in the first example. Let us denote first function by u and second function by v. Our aim is to differentiate first function with respect to another, means we have to differentiate first function. Now first function means what? U, and second function means what? V, means we have to differentiate u with respect to v. As it stands, both the functions are inverse trigonometric function. Whenever the functions are inverse trigonometric, we are trying to simplify it using substitution method also. So here if we are replacing x by tan x, 2 tan, we will get what? Tan theta upon 1 plus tan square theta, and here if I am replacing x by tan theta, we will get 1 minus tan square theta upon 1 plus tan square theta. Means in both the cases we are able to convert this expression in terms of double angle formula, and if in both the functions substitution is same, example will become what? Very easy. So here we are substituting x is equals to what? Tan theta. So put x is equal to tan theta, so therefore u will become sine inverse of, first let us simplify u, so 2 tan theta upon 1 plus tan square theta. Just simply we are replacing x by tan theta, so which is equal to sine inverse, keep it as it is. Now 2 tan theta upon 1 plus tan square theta is nothing but value of what? Sine 2 theta according to double angle formula. So now according to one of our property of inverse trigonometric function, sine inverse of sine theta will be equal to theta, but theta is what here? 2 theta, means in short sine and sine inverse will get eliminated according to our one property of inverse trigonometric function. So here u is in the simplest form. Now we are simplifying v. So v is equal to cos inverse of, again replace x by tan theta, so here we will get 1 minus tan square theta divided by 1 plus tan square theta. Just simply replace x by tan theta, so cos inverse, keep it as it is, 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. So here again according to property of inverse trigonometric function, cos inverse and cos will get eliminated, remaining term will be 2 theta. So value of u in terms of theta and v in terms of theta is known to us. Now we are finding our required value. So we have to find out what we have to find out? Derivative of u with respect to v, means du upon dv. So therefore du upon dv is equal to, now here we are trying to make this example very easy, since in both the cases same substitution is there. अगर इसे सिंप्लीफाई करते हैं तो थीटा की वैल्यू क्या मिलेंगे हमें? tan इनवर्स ऑफ x, यहाँ पे भी tan इनवर्स ऑफ x और यहाँ पे भी थीटा की वैल्यू tan इनवर्स ऑफ x, यानी दोनों भी फंक्शन में अगर substitution same है, so what is our substitution? X is equal to tan theta, that's why value of u we have got in terms of theta and v also in terms of theta. So now let us consider theta is our new parameter, getting it? Initially our parameter is what? X, because value of u is also in terms of x and v is also in terms of x. But since in both the cases, in both the function, if substitution is same, at that time only we are able to consider this theta as what? New variable. So now du upon dv can be written as du upon d theta, because we are differentiating it with respect to theta, because theta is now our new parameter. So which is equal to, in the numerator, d by d theta, keep it as it is, u I am replacing by its value 2 theta. In the denominator also, d by d theta, keep it as it is, replace v by its value. Value of v is also 2 theta. Now derivative of 2 theta with respect to theta is 2, and derivative of 2 theta with respect to theta is 2. 2 upon 2 will be equals to what? 1. Means our required value means du upon dv will be equals to what? 1. In this way we have got the required differentiation. Now observe the example number 3rd. In this example also we have to differentiate first function with respect to another. So we are denoting first function by u and second function by v. We have to differentiate first function with respect to v, means we have to differentiate u with respect to v, means we have to find out du by dv, which the method we have seen in the last two example. In this case the function is inverse trigonometric, here also inverse trigonometric. Whenever the function is inverse trigonometric, to simplify it we are using substitution method. here under root 1 minus x square is there. So in such, if such expression appears, at that time what is our substitution? X is equal to sin theta or x is equal to cos theta. तो यहाँ पे हमें दो choices है, either substitute x is equal to sin theta or cos theta, and in this case in the denominator 2x square minus 1 is there. If I am replacing x by cos theta, so what will get? 2 cos square theta minus 1, which is nothing but value of what? Cos 2 theta. So means here in this case what should be our substitution? X is equal to cos theta. और यहाँ पे हमें दो choices है, x is equal to sin theta और x is equal to cos theta, लेकिन दोनों भी जगह पे same substitution अगर हम रखते हैं तो example easy हो जाता है. That part already we have seen in the first example. So that's why in both cases we are using which substitution? X is equal to what? Cos theta. यहाँ पे दो choices है, sin भी कर सकते cos भी, लेकिन यहाँ पे cos ही करना पड़ेगा और दोनों जगह का substitution सेम आना चाहिए, इसलिए हम क्या सब्स्टिट्यूट कर रहे हैं? पुट x इज इक्वल टू cos थीटा इन u and v. So therefore u will become, so u will be equals to tan inverse of here x I am replacing by cos theta in the denominator under root 1 minus cos square theta, because x we are replacing by cos. First let us simplify it. Tan inverse, keep it as it is, cos theta also as it is, under root 1 minus cos square theta according to identity will be equals to sin square theta. So tan inverse, keep it as it is in the numerator, cos theta as it is in the denominator, sin square theta outside the root will become what? Sin theta. Now according to interrelation between trigonometric function, cos upon sin will be equals to what? Cot theta. If we are able to convert cot in terms of tan, then tan inverse and tan will get eliminate according to our one property of inverse trigonometric function. That's why we are trying to convert cot in terms of tan, and to convert cot in terms of tan we are using allied angle formulas, that tan pi by 2 minus theta, tan pi by 2 minus theta is equal to cot theta, means cot theta can be written as tan pi by 2 minus theta. Now according to our property of inverse trigonometric function, tan and tan inverse will get eliminated, remaining term will be pi by 2 minus theta. Now again use the same substitution in v is equal to 1 upon sec inverse of 1 upon 2. X I am replacing by what? Cos. So here we will get cos square theta minus 1. So which is equal to sec inverse, keep it as it is, 1 upon 2 cos square theta minus 1 is the value of cos 2 theta. So which is equal to sec inverse, keep it as it is. So we know that reciprocal of cos is what? Sec. So cos 2 theta, if we are taking its reciprocal we will get sec 2 theta. Now sec inverse and sec will get cancelled, 2 theta, isn't it? Now value of v is also in terms of theta and u is also in terms of theta, and in both the cases value of theta is same, that cos inverse of x, isn't it? That's why here, since in both the cases value of theta is same, so now we are considering theta as our new parameter, because value of u is also in terms of theta and v is also in terms of theta. So let us consider theta is our new parameter. So now we are finding our required value, means derivative of u with respect to v. So since value of u is also in terms of theta and v is also in terms of theta, so both u and v we are differentiating with respect to theta. So replace this u by its value. What is the value of u? Pi by 2 minus theta. And v, what is the value of v here? 2 theta. So which is equals to, what is derivative of pi by 2? 0, and derivative of minus theta is minus 1. Derivative of 2 theta will be equals to 2. So minus 1 by 2 is the value of our required differentiation. See in the next example number 4th also, we have to differentiate one function with respect to another. So that's why we have denoted first function by u and second function by v, and here also we have to differentiate first with respect to second, means derivative of, we have to differentiate u with respect to v, means our required value is du upon dv. So same method we are applying which we have applied in first 3 example. Here also function is inverse trigonometric. So let us check whether it is possible to simplify it using substitution method or not. If I am substituting x is equal to tan theta, so 1 minus tan square theta upon 1 plus tan square theta, it's cos 2 theta, and cos if we are able to convert this expression in terms of cos and cos inverse will get eliminated according to property. And here also if I am replacing x by what, tan, यहाँ पे भी tan substitute कर रहे हैं और यहाँ पे भी tan, अगर tan substitute करते हैं तो tan inverse और tan eliminate हो सकता है, means in both the cases we are using same substitution. So here substitute means put x is equals to tan theta in u and v. Let us see what we will get. So therefore u will become cos inverse of 1 minus, replace x by tan, so x square means tan square theta, in the denominator also replace x by tan. So which is equals to, we know that according to double angle formula 1 minus tan square theta upon 1 plus tan square theta is the value of cos 2 theta. Now according to property of inverse trigonometric function, cos inverse and cos will get cancelled, remaining term is 2 theta. Now consider v is equal to what, tan inverse of, here also I am replacing x by what, tan theta. So here tan inverse and tan will get eliminated, value of v will be equals to theta. So value of u in terms of theta is also known to us and v in terms of theta is also known to us. Now we are finding our required value, that is du upon dv is equal to, so d upon d theta, because u is also in terms of theta and v is also in terms of theta. So that's why we are differentiating u and v both with respect to theta. So now remaining part is just to substitute the value of u, which is equal to 2 theta, and v will be equals to what, theta. So which is equals to, now derivative of 2 theta with respect to theta is 2 and derivative of theta with respect to theta is 1. So 2 upon 1 will be equals to 2. So 2 is the value of required differentiation. Now see, in the example number 5th also we have to differentiate first function with respect to another function. So we have denoted first function by u and second function by v, and we have to differentiate first function means u with respect to second function means v, means we have to find out derivative of u with respect to v. So we have to find out how to find out du by dv. And to find out the value of du by dv, we have to find out first differentiation of u with respect to parameter x and v also with respect to parameter x, because value of u and v are in terms of x. So first we are finding value of derivative of u with respect to x. So differentiate it with respect to x. So derivative of u with respect to x is denoted by du by dx. On this side function is in the form of a raised to power x. And what is derivative of a raised to power x? A raised to power x into log a, where a is nothing but 3 here. Let us denote this value by equation number first. Now consider v, and v is equal to, what is the value of v? Log of 3 to the base x. First I am simplifying it using laws of logarithm. So using one of the laws of logarithm, log a to the base b can be written as log a upon log b using base change formula. And here new base, we have not written anything in the base, means new base is e here, isn't it? And not necessary to write e. In case of calculus we are studying about natural logarithm, and in case of natural logarithm base is nothing is there in the base, means e is always there. Which formula we have applied here? Log of a to the base b is equals to log a upon log b to the new base. New base here I have denoted by m, but here nothing is written in the base, means we have denoted new base by e. Now we are differentiating it with respect to x. So differentiate it with respect to x. So let us see what differentiation we will get here. So dv upon dx will be equals to, log 3 is a constant term, keep it as it is. Now derivative of 1 upon log x. 1 upon log x is in the form of 1 upon f of x. And what is the derivative of 1 upon f of x? Minus 1 upon square of f of x. Square of f of x means square of log x into derivative of f of x. What is f of x? Log x, isn't it? So log 3 is a constant term, keep it as it is. Remaining term is in the form of 1 upon f of x. Its derivative is minus 1 upon square of f of x into derivative of f of x. Let us simplify it. So which is equal to, here minus into plus will be minus, and log 3 into 1 will be equal to log 3. log 3, in the denominator log x whole bracket square, keep it as it is, and into derivative of log x. What is derivative of log x? 1 by x, which can be written as minus log x in log 3 into 1 is minus log 3, and in the denominator x into log x whole bracket square, keep it as it is. Let us denote this value by equation second, which is nothing but value of dv upon dx. Once both the values are known to us, now we are finding our required value. We have to find out value of du by dv. So here we can observe that u is also in terms of x and v is also in terms of x. So that's why du upon dv can be written as du upon dx divided by dv upon dx. Already these differentiations are known to us. Derivative of u with respect to x will be equals to 3 raised to power x into log 3, and derivative of v, just now we have got it, minus log 3 divided by x log x whole bracket square. So which is equal to 3 raised to power x into log 3, keep it as it is, into, so this minus I am shifting it in the numerator, ये term divided है, multiply किया तो reciprocal हो जाएगा, x log x whole bracket square divided by what? Log 3. Here easily we can observe that log 3 will get cancelled. Write down the remaining term minus, first write down x, then write down 3 raised to power x into log x whole bracket square, which is nothing but our required value du upon dv. Observe the next example. In this example, we have to differentiate this first function with respect to what? Another function. So here denote first function by u and second function by v. We have to differentiate first function with respect to another, means we have to differentiate u with respect to v, means our required value is du by dv. So here we can observe that value of u is in terms of x and v is also in terms of x, means x is our parameter. So first we are finding differentiation of u with respect to x. But here it is inverse trigonometric function, so let us simplify it and try to convert it in terms of what? Tan. So observe here, tan inverse, keep it as it is, according to property of, according to half angle formula, cos x can be replaced by cos square x by 2 minus sin square x by 2, and in the denominator 1 plus cos x can be replaced by cos x by 2 plus sin x by 2. In both numerator and denominator we are applying half angle formula, isn't it? So all these result we have got applying half angle formula, so which is equal to tan inverse, keep it as it is. In the numerator terms are in the form of a square minus b square, whose factors are a plus b into a minus b, means here we will get cos x by 2 plus sin x by 2 means a plus b into a minus b. A minus b means cos x by 2 minus sin x by 2. Just simply we have applied half angle formula in we have applied which identity? A square minus b square is equal to a plus b into a minus b. Keep the denominator as it is. What is denominator? Cos x by 2 plus sin x by 2 whole bracket square, keep it as it is. So here easily we can observe that from numerator and denominator, cos x by 2 plus sin x by 2 and one term of cos x by 2 plus sin x by 2 from the square will get cancelled. After cancelling cos x by 2 plus sin x by 2 from numerator and denominator, here remaining term in the numerator is cos x by 2 minus sin x by 2, and in the denominator cos x by 2 plus sin x by 2. One term from denominator will get cancelled, isn't it? Square is there, one term from numerator and denominator will get cancelled. After that I am dividing to numerator and denominator by cos x by 2. Let us see what we will get here. So this is nothing but value of u is equal to tan inverse of, if I am dividing to numerator by cos x by 2, so cos x by 2 upon cos x by 2 is 1 minus sin x by 2 upon cos x by 2. Sin upon cos means what? Tan. Since we are dividing to numerator, that's why I divide to denominator also by cos x by 2. Cos x by 2 upon cos x by 2 is 1 plus sin x by 2 upon cos x by 2 is what? Tan x by 2. So which is equals to tan inverse, keep it as it is, this 1, can I replace 1 by tan pi by 4? Yes, tan pi by 4 minus tan x by 2, keep it as it is. In the denominator, 1 as it is plus also as it is. Here tan x by 2 also as it is. What is the coefficient of tan x by 2? Here nothing is there, means 1 is there. 1, can I replace it by tan pi by 4? Yes, 1 can be replaced by what? Tan pi by 4. This adjustment we are doing just to arrange the term in the form of formula of tan a plus a minus b. What is the formula of tan a minus b? Tan a minus tan b upon 1 plus tan a into tan b, isn't it? Which is nothing but formula of tan a minus b. A is what here? Pi by 4 minus b. B is what here? X by 2. In this way, simplifying this expression, we have converted it in terms of tan. Now we are able to apply our property of inverse trigonometric function, which says that tan inverse and tan will get eliminated, and remaining term is pi by 4 minus x by 2, which is nothing but value of u. So now we are differentiating u with respect to x. So derivative of u with respect to x is denoted by du upon dx, and here differentiation of pi by 4 is 0, minus 1 by 2 is a constant term, derivative of x is 1, not necessary 1 here. So minus 1 by 2 is our first required value. Now we are considering v, and v is equal to, what is the value of v? V is equal to sec inverse of x. Now we are differentiating it with respect to x. So derivative of v with respect to x is dv upon dx. And what is derivative of sec inverse of x? We know that its derivative is 1 upon x under root x square minus 1. It is the standard formula. Let us denote it by equation number 2. Once the value of du upon dx and dv upon dx is known to us, applying the formula of differentiation of parametric function, we are able to find out our required value. So let us try to find out our required value. So therefore, du upon dv can be written as du upon dx divided by dv upon dx, which is nothing but formula to find out differentiation of parametric function. What is the derivative of u? That is minus 1 by 2. So replace numerator by its value minus 1 by 2 and denominator by its value 1 upon x under root x square minus 1. So which is equal to minus 1 by 2, keep it as it is. ये term divided अगर multiply होंगी तो x upon x square minus 1 divided by 1. We have to take its reciprocal if we are multiplying. So here in the numerator minus 1 into this term means minus x under root x square minus 1, and in the denominator 2 into 1 will be equals to 2, which is nothing but value of du upon dv. So in this way we have got our required differentiation. Now see in the example number 7th, here also we have to differentiate x raised to power x with respect to x raised to power sin x. Means we have to differentiate one function with respect to another function. Already in the last 6 example we have seen that in such cases we are using the formula to find out differentiation of parametric function. So let us denote first function by u and second function by v. We have to differentiate first function with respect to second, means we have to differentiate u with respect to v, means our aim is to find out value of du upon dv. Now to find out value of du upon dv, first we will require the differentiation of u with respect to parameter x, then derivative of v with respect to parameter x. So we are considering u is equal to x raised to power x, but here to differentiate this function, first we have to observe that the function is in the form of, here we can observe that the function is in the form of f of x raised to power g of x. In such cases we have to apply logarithmic differentiation method, means we have to solve this example by taking log on both sides. So taking log on both sides. If we are taking log on both sides, means indirectly we can say that we are applying logarithmic differentiation method. This method is called as what? Logarithmic differentiation method. Simply we have taken log on both sides. So on this side, according to laws of logarithm, this power can be taken as coefficient. So here we will get x into log x, and here log u, keep it as it is. Now we are differentiating it with respect to x. First our aim is to simplify it using laws of logarithm, and then the simplest form we are differentiating. Differentiate it with respect to x. What is derivative of log u? Is 1 upon u into derivative of u is du by dx, because it is in the form of log f of x. Instead of x, another term appears. We will consider it as what? F of x. It is in the form of log f of x, so its derivative is 1 upon f of x into derivative of f of x. F of x is u here. On this side, to find out the derivative, we have to apply product rule. According to product rule, first term as it is into derivative of second term. Second term is derivative of log x, plus second term as it is, log x as it is, into derivative of first term. First term means what? X. So du upon dx will be equals to, u will get multiplied on this side. On this side, x, keep it as it is. What is derivative of log x? 1 by x, plus log x as it is. What is derivative of x? Will be equal to 1. So du upon dx will be equals to, I am replacing u by its value. What is the value of u? X raised to power x. And here let us simplify it. X will get cancelled, remaining term is 1, and here log x into 1 will be equal to log x. In this way we have got the differentiation of u. Let us denote it by equation number first. Now consider the second function v, and v is equals to, what is v here? X raised to power sine x. So here also, to differentiate it, we have to use logarithmic differentiation method, since the function is in the form of f of x raised to power g of x. So taking log on both sides, log on both sides, what we will get here? On this side we will get log v, and on this side we will get log of x raised to power sine x. On this side, according to laws of logarithm, this power can be taken as an coefficient, means sin x can be taken as an coefficient. Now we are differentiating it with respect to x. So let us differentiate it with respect to x. What is derivative of log v? Will be 1 upon v into dv upon dx. On this side, to find out differentiation, we have to apply product rule. According to product rule, keep first term as it is, means sin x as it is, into derivative of second term. What is second term here? Log x, plus second term as it is, means log x as it is, into derivative of first term, means first term is what here? Sin x, into derivative of what? Sin x. In this way we have applied here product rule. So dv upon dx, keep it as it is. v इधर divided है, इधर आके multiply हो जाएगा. So let us simplify this side. Sin x, keep it as it is. What is derivative of log x? 1 by x, plus here log x, keep it as it is. Log x as it is. What is derivative of sin x? Will be equal to cos x. So now I am replacing v by its value. What is the value of v here? X raised to power sin x, x raised to power sin x, and here I am taking cross multiplication. Here nothing is in the denominator, means 1 is there. 1 into sin x will be equal to sin x, plus x will get multiplied on this side. So here x log x into cos x, isn't it? And divided by x into 1 will be equal to x, because nothing is there, means 1 is there. Simply we have taken cross multiplication. Let us denote this result, say, by equation number 2, which is our second required value, means derivative of what? V. Once these two values are known to us, now we are finding value of du upon dv, means our required value. We have to differentiate u with respect to v. So here, what is the theorem to find out derivative of parametric function? Du upon parameter. What is parameter here? X, because value of u is in terms of x and v is also in terms of x, means we can say that parameter is x. So du upon dx divided by dv upon dx. Remaining part is just to substitute the value. Now du upon dx, according to equation number first, will be equal to x raised to power x into 1 plus log x. And from equation number 2, what is the derivative of v? Will be x raised to power sin x into sin x plus x log x into cos x divided by x. In this way we have got the differentiation. Now only the remaining part is to simplify it. So try to understand the simplification part here, so which is equals to, now here in terms of x appears 1, 2, 3. In this case base are same. What is the base here? X. Here also base is x, here also base is x. then if base is same, then according to laws of exponent, means which are also called as laws of indices, we are able to collect all these terms, isn't it? चलो यहाँ पे x का पावर कितना है, x. अभी ये जो x है, ये x डिवाइडेड है, ये कहाँ पे शिफ्ट हो जाएगा, न्यूमरेटर में, क्योंकि ये मल्टीप्लाई किया तो ये x कहाँ पे आएगा, न्यूमरेटर में. व्हाट इज द पावर ऑफ x हियर, 1. सो +1, बिकॉज इफ दिस टर्म इज इन द न्यूमरेटर मीन्स देयर प्रोडक्ट इज देयर, एंड वी नो दैट a raised to power m into a raised to power n विल बी इक्वल्स टू पावर a raised to power m plus n. तो इनके बेस सेम है, इसलिए पावर की क्या हो जाएगी, एडिशन. और ये जो टर्म डिवाइडेड है, अगर इसे ऊपर शिफ्ट किया तो प्लस साइन x विल बिकम व्हाट, माइनस साइन x. Just we are collecting these three terms, applying what, laws of exponent, that a raised to power m divided by a raised to power n will be equal to a raised to power m minus n. So here division is there, that's why we have to take the subtraction of power. So how many terms of x are there, 3 terms. We have collected these 3 terms using laws of exponent. ये x न्यूमरेटर में आ गया, तो यहाँ पे उसका पावर 1 है, सो x raised to power 1 into x raised to power x will be x raised to power x plus 1, and this term is in the denominator, divided है, तो इसलिए क्या हो जाएगा, माइनस sin x, isn't it? Keep remaining term as it is. What is the remaining term, 1 plus log x, and here in the denominator already we have shifted this term in the numerator, so remaining term is sin x plus x into log x into cos x, and this will be our required value of du upon dv. Now see the example number 8. In this case also we have to differentiate one function with respect to another function. So we are using same method, denote first function by u, second function by v. We have to differentiate first function with respect to another, means in other word we can say that we have to differentiate u with respect to v, means we have to find out value of du upon dv. But as a stand, given functions are what, inverse trigonometric function. In such cases, if algebraic expression appears here, so we have to check that is it possible to simplify it using substitution method or not. So see here, if 1 plus x square appears, at that time what is our substitution, x is equal to tan theta, means we are able to simplify it using substitution method. And here which expression appears, 1 minus x square. In such cases our substitution is x is equal to sin theta to simplify it, isn't it? Means in both the cases our substitutions are different. So already we have solved some example in which in both the cases, means in the first part also and in the second part also same substitution is there. So in that case we are getting value of u in terms of parameter theta and v is also in terms of parameter theta, and that new variable theta we are considering as an parameter. But here in both u and v different substitutions are there, so we are not able to apply the method which we have applied in last some 2-3 examples, isn't it? Here we are substituting what is our substitution, x is equal to tan theta. Let us substitute x is equal to tan theta and see what we will get. So you will become tan inverse of here under root 1 plus replace x by tan theta. So x square means what, tan square theta, minus 1, keep it as it is. In the denominator also replace x by what, tan theta. Let us simplify it, and later on we will simplify v also. So which is equal to tan inverse of here 1 plus tan square theta according to identity will be equal to sec square theta. Keep this minus 1 as it is. In the denominator tan theta, keep it as it is. Okay, so which is equal to tan inverse of, now here sec square outside the root will become sec theta, minus 1 divided by what, tan theta, isn't it? So which is equal to tan inverse of, now I am trying to convert it in terms of sine and cos, so that easily we are able to use our formulas, double angle, triple angle, half angle. So this sec can be written as 1 upon cos theta, minus 1, keep it as it is. In the same way tan can be replaced by sin theta upon cos theta, isn't it? If you observe here denominator is cos and here also cos. To eliminate this cos I am multiplying to numerator and denominator by cos theta. So first check what result we are getting if we are multiplying to numerator by cos. So multiply to numerator by cos, how many terms are there? 2 terms are there. First multiply to first term by cos. If I am multiplying to first term by cos, cos and cos cos will get cancelled. Here remaining term is 1. Now multiply to second term by cos. 1 into cos will be equal to cos theta. As we are multiplying to numerator, that's why we are multiplying to denominator also by cos theta. If I am multiplying here by cos theta, cos and cos will get cancelled. Remaining term is what? Sin theta, isn't it? So again it can be simplified. So observe here, so which is equals to tan inverse of here 1 minus cos square theta according to half angle formula will be equals to 2 sin square theta by 2, and in the denominator sin theta will be equals to sin theta by 2 into cos theta by 2. Just simply we have applied half angle formula in both numerator and denominator. So which is equal to tan inverse of 2 and 2 will get cancelled, sin theta by 2 and 1 sin theta by from in numerator will get cancelled. So remaining term in numerator is sin theta by 2 and in the denominator it's cos theta by 2. So which is equal to tan inverse of, now sin upon cos is nothing but tan theta by 2. So which is equals to tan inverse and tan will get eliminated according to our property of inverse trigonometric function. So this is the value of u. So therefore u will be equals to, so 1 by 2 is a constant term, keep it as it is, just I am replacing theta by its value. So if x is equal to tan theta, then theta is equal to what? Tan inverse of x. So I am replacing this theta by tan inverse of x, isn't it? Here we are not able to consider theta as a parameter because in both the part value of theta are different. Because in first part our substitution is x is equal to tan theta, and in second part our substitution is x is equal to sin theta. Now in this second part we are substituting x is equal to what? Sin theta. So let us see what we are getting if we are substituting x is equal to what? Sin theta. So here v will become tan inverse of, now observe it very carefully, 2x can be replaced by sin theta under root 1 minus x square. 1 minus x square means 1 minus sin square theta, and in the denominator 1 minus 2, again replace x by sin theta. X square means sin square theta. Just simply we have substituted the value of x is equal to what? Sin theta. So in the numerator 2 sin theta, keep it as it is, under root 1 minus sin square theta is cos square theta, and in the denominator 1 minus 2 sin square theta is the value of, is it the value of cos 2 theta according to double angle formula? Yes, its value is equal to what? Cos 2 theta. Cos 2 theta is 1 minus 2 sin square theta. Now in the numerator let us check what we will get, tan inverse of. So 2 keep it as it is, sin theta also as it is, cos square theta outside the root will become cos theta. In the denominator cos 2 theta, keep it as it is, so which is equal to tan inverse of. Now if you observe numerator very carefully, 2 sin theta into cos theta. 2 sin theta into cos theta is nothing but value of what? Sin 2 theta according to double angle formula. In the denominator cos 2 theta, keep it as it is. So tan inverse of sin upon cos will become what? Tan. So here we will get tan 2 theta. Tan 2 theta. Now our one property says that tan inverse and tan will get cancelled. So here v will be equals to 2 theta. So I am now replacing theta by its value. What value of theta we will get here? Sin inverse of x. So that's why here we can say that. So therefore, otherwise here substitute the value, v is equals to 2 sin inverse of x. This value we have obtained from our substitution. If x is equal to sin theta, then if we are taking sin inverse on both sides, on this side we will get sin inverse of x, and on this side sin inverse and sin will get cancelled. Remaining term is theta, means theta is equal to sin inverse of x. Once the value of u and v in terms of x are known to us, so differentiate it with respect to x. So differentiate it with respect to x. So derivative of u with respect to x is du upon dx. On this side 1 by 2 is a constant term. What is derivative of tan inverse of x? 1 upon 1 plus x square. So which can be written as 1 into 1 is 1, and in the denominator 2 into 1 plus x square is 2 into 1 plus x square. Now consider the value of v. What value of v we have got here? V is equals to what? 2 sin inverse of x, isn't it? v is equal to 2 sine inverse of x. We are differentiating it with respect to x. So differentiate with respect to x. So derivative of v with respect to x is dv upon dx. On this side 2, keep it as it is. What is derivative of sine inverse of x? 1 upon under root 1 minus x square. So which is equal to 2 into 1 will be equal to 2 upon under root 1 minus x square, which will be the value of dv by dx. Once the value of du by dx and dv by dx is known to us, we are able to find out our required value. So what is our required value? Du upon dv, so will be equals to, so according to formula of parametric function, du upon dv can be written as du upon dx divided by dv upon dx. Now remaining part is just to substitute the value. What is the value of du upon dx? Du upon dx is 1 upon 2 into 1 plus x square, isn't it? And dv upon dx will be equals to 2 upon under root 1 minus x square. So let us see what we'll get here. Easily we can observe that ये टर्म डिवाइडेड है, मल्टीप्लाई करेंगे तो क्या होगा? इसका रेसिप्रोकल होगा. रेसिप्रोकल होगा बोले तो ये टर्म न्यूमरेटर में आ जाएंगी. मीन्स व्हाट विल गेट इन द न्यूमरेटर? अंडर रूट 1 माइनस एक्स स्क्वायर. एंड इन द डिनोमिनेटर व्हाट विल गेट? 2 into 2 means 4 into 1 plus x square. And this is nothing but our required differentiation. So again see here, ये टर्म डिवाइडेड है, मल्टीप्लाई करेंगे तो इसका रेसिप्रोकल हो जाएगा. रेसिप्रोकल हो जाएगा बोले तो ये न्यूमरेटर में आएगा और 2 डिनोमिनेटर में, 2 into 2 will become what? 4. In this way we have got our required differentiation. So in this way we have completed all the examples from this exercise. Means we have completed the differentiation of parametric function. In the next video we are starting the last article from this chapter, that is higher order derivative. So if you think that these videos are very helpful to you, so please like the videos and share these videos with your friends also. If you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded videos.